Hey guys, today we're going to be remaking a classic minigame from Final Fantasy VIII called Triad in Unity. I'm going to go over the basics of like how to make a card, how to make card data, the shader involved in making that card, and then obviously being able to set up a board, put the cards down on that board, have those cards, as you can see in this gameplay behind me, as a card touches another card, if the number in that direction is larger, they flip a card over. So for example here, that unit that just got put in the bottom left, because it's got 6 on the top and that was bigger than the 3 on the bottom of the card beneath it, it flips the card. So I'm just going to go into Unity and I'm going to showcase what I've built so far. So here we are in Unity, so the version I made earlier. So what we've got here is the board, the cards that we can select and place. So if we place a card, the AI currently just places them randomly. As you can see here, the card I'm selecting has numbers on it. It will flip any cards on the board depending on how their numbers correlate. So the 9 on this card would relate to the 2 on the enemy card, therefore I'll flip it. And then because he played this card with a 6 here, and that 3 is representing the left, he flips that. And so we keep playing until the game finishes. And then I've got it so the game stops here. So you could do a game over screen or win-lose screen depending on the board count. Okay, so the first thing we're going to need to do to make this game is set up basically a card prefab, a default card that all our card data can go onto and change as required. So the first thing I'm going to do is create an empty game object. I'm going to call this card prefab tutorial, and then I'm going to add a plane to it. So I'm going to add a 3D object and I'm going to add a plane. I'm just going to child that to the prefab. And on this plane, I can probably delete the mesh collider because we're going to put the collision data here on the actual prefab. And just so I get this in, I'm going to scale it 1.8 to 1.7, just because that will be the size of my particular cards, just how I've set up the board and so on so far. Okay, so as you can see, the material on the card is the default material, so it's just appearing white. We're going to need to create a material and a shader for the card. We go to shader graph, so we right click, create shader graph, built in, and it can be a unlit shader graph. And we'll just call this card shader, and then I'll open this up. So the first thing I want to do for the card is to create a background. If you remember in the game, if I look, let's just scroll here, the top of the background is slightly light blue and then it's a darker blue at the bottom. So we're just looking to make a gradient. The easiest way to do that, we could just make a gradient in Photoshop and then import it in. But we could just use a UV node as well, because that's essentially a baked-in gradient. So we'll pull out the green channel. And what we want to do is we will want to tile it. Tiling and offset. Go into the UV and then out. We'll need to split. And we'll need to pull out, let's see, the green channel. We're going to multiply this. So we're going to need to create a color. So the color we were using is blue for the friendly card. So we'll just do that to begin with. So we'll create a color variable over here and we'll call it card background. And this is a color. We can set it to, let's say, blue. This is its reference here, which we may change. But for now, I'll leave it as underscore card background. Everything else is fine. So if we pull this into the shader, we multiply it by the UV. Basically, what we're doing here is we're taking the green, where it's at the top, there's a lot, and then there's not a lot here. And we're essentially turning it into a background. I'm going to offset this in the Y slightly, just so it's more akin to what we were looking at earlier. And I think that's fine. We're just getting a simple gradient. And then what I want to do is plug this into the fragment color. So now any material with this shader will just have a gradient from light blue to slightly darker blue on it. So we'll save the asset. we'll go into our scene and we'll right click create and we'll create a new material. If I can see it, there we go. And I'm just gonna, I wonder if I can drag it, no. I'm gonna use shader graphs, and then this is the one we're working on currently. And so I've made the material and I can throw it on here and we've got it working just as intended. It is, no, what degree would that be? What axis, sorry. Is it this? And it'd be 180. Okay, it was upside down for what I wanted, but this looks perfect. So this is the background part of the card. But now we're going to want to be putting images onto it as well. So we'll now need to go back into the shader and add those. So going back into the shader, we're going to now want to add another variable to our shader. Now, the reason we're doing variables in this case is we'll be able to change this color using a C# script. So we can go from blue to red when the card goes from ours to the enemies. As you can see, I'll just scroll through, right? So it's blue when it's ours, red when it's the enemy card. We also want to put in a variable for a texture 2D, and we'd call this card image. And essentially what this will be is the specific card image that we're going to be using. So for example, I can use the character image. There's a sample 2D node over here, which we were going to need, but we want it to be this texture. Sorry, I was on the wrong thing. So it's here, put in the character, and then from here, we've got an image. So we're going to want to add these two images together. So your instinct may be to use an add node. So you're like, oh, I add this color and I add this image, and oh, we get the blue mixing with the green, which isn't really what we want. What we actually want is a blend node. We put it into the base. We're going to want it in the bottom base, I believe, and then the top base will be the blue background. And then instead of overlay, we've got all of these blend options. So if you've ever used Photoshop and you've got multiple layers, you can choose how they interact with each other, or any editing software generally has these sorts of options. Standard would be overwrite, and then so we're just overwriting this image here with this one here. We want to take its alpha value because this is a PNG with a alpha background, and we're going to want to apply it. And so what we get is essentially just a nice clear-cut image overwritten on top of the background. Now, I am going to need a UV node because I'm going to plug this into here. In fact, I want a tiling and offset node also. Because I need the numbers to fit on my card, so if we plug this in as is, we save and go to the scene. I need to give it a card image for now. You'll notice in this card we have here, I've got the image, but I don't have room for the numbers that will need to be on the card and other aspects. So what I'm going to do is I'm going to put in a UV node, tile and offset. And then what we can do here is we can just tile it downwards ever so slightly. So I think it'll be in the Y, and then I can squish it. I can offset it in the Y also to bring it down a bit. Now you'll notice something here. When we tile it, we're getting a visual artifact. So you see the leg here. Essentially, when you're using an image, one of the problems you'll get if any of the border parts of the image is a, what would I say, a color pixel or something without alpha, it's basically stretching the last pixel and pulling it down because it doesn't know what should be there because there's no actual image data there. So if you're doing something with a transparent background, you basically need the entire border to be at least 1 pixel wide, full transparent, basically. I do have a fixed version of this image, so I can plug that in. I think I didn't fix the feet, but I fixed the head because the head part of the cactus was stretching. There's still some there, so I probably didn't do a great job, but essentially you just go into Photoshop and make sure this few pixels here isn't colored. but generally that will be what's causing that artifact. It's also worth noting, because I pulled these images from earlier, their wrap mode is clamp and not repeat. So if I made them repeat and I tile them, and that's the wrong one anyway, let's just turn that back, sorry. If I make this repeat in its image settings, what we'll get here now when I tile or offset it is just a repeated image. We obviously don't want that. We just want one image. So we have to make sure it's clamp in the image settings. This is something that you'll come up with a lot in shader graph if you're ever dealing with images. But there we've pretty much set up the basic part of it. So we've got the image, the background. I think one last thing I'll add, and I won't do this as a variable because this is going to be static, is I want to add this. So it's another blend, and this is just the border for the card. So blend, we want this to be in base 4 or base 2. Blend this over this. We're going to not overlay but overwrite, and then we want the opacity coming from this image, and that way we're able to add the border to our card simply. In the same way we added the cactus character to the background, we added the the border to the card. So we save this asset, and there we go. We've got a pretty clean example of a default card. Now, what we'll also need to do, I'll probably make it a little bit smaller, honestly. So pull it down ever so slightly, and then make it ever so squished. It might look a little too squished. Just trying to make it so we have room for the numbers we're going to add in the top left corner. But yeah, I'm pretty happy with that so far. So the next thing I'm going to need to do is put the numbers in the top left corner for this card. We're going to need to go to right click, 3D object, and then text mesh pro. And I'm just going to call this up. In fact, yeah, that should be fine actually. I'm going to call this up. I'm going to make sure it's rotated correctly. Okay. So I'm just going to rotate the text, and I'm going to put it at 90 and 180. I'm just going to elevate it ever so slightly. This will be in the -Z. And then it can even be less than that, but it'll be here and it'll be 0, 1. And that's just so the text doesn't clip. Now I'm just going to put 0. I'm going to have it centered and centered. I'm just going to bring this in. I'm probably going to scale it down also, and I'm just going to move it across here to here. It's probably far too large. 12, too small. 16, probably about right. And I'm going to just duplicate this 4 times. So I can do Control D, Control D, Control D. And so this will be up, down, and then this can be left, and then this can be right. Now, obviously, if you were doing this in a real game, you probably want to make sure everything's perfectly aligned, everything looks good. But just here, I'm just trying to showcase the core principles of what we would want to be doing. So if I deselect it, it mostly looks all right. It's a little misaligned, the left. And you could obviously pick a better font, or even, potentially format the text in a way you prefer. So we've got our basic card prefab. This is pretty much done, but we're now going to need to plug in data, because essentially what I've done here is I've told it it's blue, I've told it which image to use, but in fact I need it to use different images depending on what card it is, and different number data depending what card it is. So what we need to now create is a scriptable object in which we plug in all that data. Okay, so to create the card data, we're going to go right click, create, and we need a C# script. I'll call this card data, and then we'll open this up. So we've got the card data here. I'll just maximize it. So we don't need any of this, and we're actually not going to be using a mono behavior. We're going to be calling this a scriptable object, because we're essentially, this isn't code that's going to be run. It's just a class in which we define the data that will be on a card. So for example, we'll need a public string. So a string is a string of letters. So like the card's name. It's automatically filling this out because I've already created this in the file, but we will call this card name. We will also need a public texture 2D, and this is of course going to be the card texture. We will need, then I think the last four things would be public int, and then it's going to be up number, so the number going upwards on the card, down number, left number, and right number. Cool. And then so we also want to be able to create a new scriptable object from the menu system. So what we can do here is use create asset menu, and then it's going to be file name equals new card, and this needs to be in quotation marks, and then menu name, small m, menu name is equal to card data, let's say. Cool. And then I'll just double check, make sure I got everything there correct. I need parentheses here and then delete this. Cool, that's perfect. So now if we go back into Unity, we can right click and create, and we've now got these menu options. Card is the one I created earlier. Card data is the one I'm showcasing you now. And now we can basically define any card, right? So we'd go into card images. Maybe that's a mistake. Wait, card images. Yeah, I'm losing that. In fact, this is a good lesson. So the reason why this is a good lesson is we can use lock here. And now when I click off onto something else, we don't lose the card data in the inspector. So we can give it an image. I can, for example, the cactus character. It's called Cactor. And then we can give it, you know, you could think about this like how you want your game to play, but I'm just going to give random numbers essentially, a 2 and a 1. And there we have the card data. So now we need a way of taking this card data, and we can make a bunch of card data. I've got tons made beforehand for all my cards. So if we unlock the inspector, this is the stuff I was using earlier. So all these characters, all their images set. And what I need to do, and again, it's just by going create card data and then filling it in with images and numbers. What I now need to do is be able to inject that into my card prefab through a script in real time, essentially. So I'll showcase you how to make that now. So the first thing I want to make sure I've done is if I go here, I'm going to take this prefab that I've been making and actually turn it into a prefab by dragging it into assets. What this is essentially doing is turning all of this that I've put into the scene into an asset that we can call upon at any time. It's essentially, think of it rather than being scene bound, it's hard drive bound, so you can just always pull this in. And look, if I pull it in, we've got an exact carbon copy. We can instantiate it from script. Obviously, we're unable to edit this version of it once the game's running because you don't want, well, to some degree, you're limited in how you edit it, but you can edit instances of it, but not the prefab itself, if that makes sense. But it's a really good way of saying like, oh, I have a card, I want to instantiate the card, and then it's always going to be the same. So I just need a pre-built, prefabricated version of that game object. So I can delete this. And so if we go into here, the actual prefab, we're going to need to add a script. I can probably just do this here, add a script, new script, and we'll call it card script is already in use. Card manager script, I think that's in use too, so I'll just put tut at the end because this is the tutorial we're doing. And then we create and add that script, and then I'm going to open that script up by double clicking it. And so the first thing we're going to want to do, we're going to want to try and define everything about our card. We're going to need a couple of public variables, and the first ones are going to be text mesh pro references to our actual text. So we've got up number, and then we've got down number, left number, right number. And then we also want public card data, and then we'll call this card data. Cool. So now if we go back to our script, we're actually able, that's not, sorry, our script. If we go back to the game object, we can actually now assign these. So we can say, look, this up number is this down number is this left number is this, and this right number is this. So whenever in the script we change any of these numbers, they'll be changing these physical numbers on our card right here. Now, I can also put in card data. So I can put in any of these card datas that I've built earlier. The problem being, oh sorry, those ones are wrong because they're the ones I've made earlier, whereas this is using the ones we just made now because it's a different name of class, card data. But essentially what we made, card data, and then this would, theoretically, we can pull from this and say, oh, I want to change the numbers from here to this to this. So to showcase you how this would look is we'd take the up number variable, we would then say set text, the text mesh pro object, and we're going to say card data, and then we're going to say up num because it's the up number, and then we're going to go to string because we're turning an int into a string so it can turn into the text, and then there we have it. And the same thing will be true for all the others. So down num, set text, and then it autofills for me, thankfully. Up num, set text, no, that was left, sorry, and then right num. Cool, set text. Cool, and all that looks good for me. And what I can also do is go into this game object. So I can just say game object dot get component. Now we need the renderer. Now it's important we look how we've set this up. So I've put the script on the parent object, but the actual what's the word? The actual renderer we need is in a child. So what I would actually have to say is get component in children renderer, and then we will need to go and change the material, and then set texture. So we're changing one of the textures, and it was, I believe it was underscore, and we can even check it just so I'm not guessing. We've got it as underscore card image. So we'll just take that data. And then what we need to do is go from our card data and we take the card texture. And so just to go over what we've done is we've essentially assigned the card data to the prefab. We've also assigned what the text mesh objects are. And so therefore we can pull the card data numbers here and put them into the text mesh objects. And we can also take the card data and put it into the game objects material, and we're essentially changing it. So if we go back into Unity, we go back into our scene, and if we press play, now obviously all the other cards from what I've made earlier are showcasing, but as you can see here, we're getting the numbers being put in, so 2, 4, 1, 5. But we can also get the images changed. So if we go here, we can change the image in the card data. So I'm just going to lock this once again, go to my images just to showcase it's working. So we'll go a new character, and then that's been changed in the card data that we're using. So we click play again, and now we have a new character. So we've basically created a card that will update based on the card data we assign it. And because I have a bunch of card data already made, we can basically create an array of this and assign it randomly. So we're getting random cards. Obviously, if you were making a game, you might want to have the player have like a set of cards they own, and then you manage the ownership of those cards and what cards they do and don't own. But here I'm just showcasing the core principle of just being able to pull card data, put it onto a card, and then have that interact with the gameplay that we create later. Okay, so now what I want to do is create all the rest of the cards script that will be interacting with the actual game. One thing I do think is worth noting is we're using TM Pro library up here. If you don't use that, a lot of this stuff doesn't work. But yeah, just make sure you've put this line of code at the top if you want to use TextMesh Pro objects in your game. Okay, so I'm going to need a little bit more data in this card manager. So I'm going to need to know a few things. So I need a Boolean. So this is a true or false variable essentially, and I'm asking the question, is the card friendly? And then I also need to know, is the card on the board or is it in my hand? So I can just say is on board. And then that's perfect. That's all I really need there. So the next thing I need to do is then create a method in which I say, and this is a private one because it doesn't need to be referenced elsewhere. I'm just going to say, hey, on mouse down. So this is a inbuilt Unity method that is essentially just going to call whenever you click the mouse on this object with this script. It does need a collider, so we do need to make sure we have a collider on our object. So on mouse down, we need to check a couple of things. We have to know, is this a friendly card? Because we don't want to be able to click on the enemy cards. So we'll say is friendly, and we need to say that it's not on the board, right? Once we put on, is on board. So the exclamation mark here is saying not, like another way to write this is equals false. So essentially what I'm asking is, hey, is this card friendly? So I can only click on my friendly cards, and then is it on the board already? So that's false. So if I'm clicking on a card that's basically, I'm saying in my hand, I want to do something. Now that thing I want to do is actually not coded yet, but it's essentially I need to tell the game manager. Game manager needs to know that card has been clicked, and then I'll use the game manager to manage the dragging of the actual card. Now you might be wondering, why can't I just have this card manage its own movement and whether or not it can be moved? You run into this problem where you have potentially 10, 20 cards on your board, whatever, right? If all of them are managing their own movement, you have a hard time saying, oh, there's already a card in the hand, because they don't have references to each other. So card 1 can't tell card 2 that card 1's being moved. So you might be able to click multiple cards, stuff like that. If you have a central game manager, you basically can structure it. So you say, okay, you're clicking on a card, you're now dragging a card. You have a variable that says you're dragging a card. Now you won't be able to click on any other cards. And if any other cards send this message, it will just return and say, look, or it will just say it's false, so we're not going to action it. And we'll use an if statement to say, like, is something being dragged? And that way you can basically have a single script that's kind of managing all your cards, all your movement. All this is doing really is assigning our values to our card visually from the card data. And it's also an object we can instantiate and have that happen automatically. And it's quite easy for it to manage its own reference to when it gets clicked. But anything else than that is probably not necessary. Now, the other visual thing we'll need to do, I'll create a new method and I'll call it public void, and then we'll say set color. And then what I'll do is bool friendly. No, sorry, is friendly. And then what we'll say is so we'll be using this method to basically say, hey, if is friendly is true, then annoying, If isFriendly is true, then we need to change the color of our card, and that will be GameObject. In fact, it's this get component in children, and then it's dot material and it's set color. So it's GameObject. So we go GameObject, get component in children, the renderer, material, dot set color. And then we'll say, forget how I named it. So let's just double check. So we can go back into our shader, and it's card background is the name of this color. And so if we go in here, we'll say this, and then we'll say, and then if we're friendly, we're just going to use a generic color blue. And that's good. And then I can create an else statement and literally just copy and paste and do the exact opposite, where we just say, you know, is it blue? If it's not friendly, we make the color red. And color.red is just going to be a pure red value. And color.blue is a pure blue value. So we can look at the color, see if we like it or not. And we can obviously, you can put in a custom color if you like. This is just the quickest and simplest way of doing it in this sense. And now this is pretty much everything we need for our card. We've got the data changing. We've got the color changing based on where it is. We can tell the game manager, hey, the card's been clicked. And then everything else is going to just be managed by the game manager. So this card script's all done. Now, before I forget, one thing I did on my other card prefab. So if we look at the card prefab from before and I spin it around, I've put a background on it. And I'll just do the same here because in the game manager, we will be flipping the cards around. So I'll just create another 3D object, plane, and I'm going to just call this card background. Theoretically, I could go into Blender, create a plane with a two-sided face, and then I could have the UVs such that I could map the background onto it as well. But it seems like a lot of work for just demonstrating what is essentially just going to be a just a static image on a plane. So I'm going to rotate it 180 degrees. And because I've rotated it 180 degrees, it's going to be facing the other way. The planes in Unity are only facing one way. I can showcase this by just moving it here, and you can see it's invisible on that side, and it has a face on that side. And then I just need to put the background image. I've made this material earlier, so I'll just use that. It's just this card background material from here. And if you wonder how to make a material, you quite literally just go right-click, create material. I'm using just a standard shader, I believe, right? Yeah, just a standard shader. And I'm literally just mapping in this background image I pulled off from online. So I've remade this shader once again. I did turn the smoothness down to 0. So just how it reflects light. But other than that, all of that's there. And if I rotate the card object, let's come out to do that. So if I rotate this card object, you can now see there's a background here. It is upside down. So I will want to rotate in the Y by 180. Perfect. So now it's facing the right way. And then I will want to put this back to 0, right? Actually, no, not that. I will want to put, no, everything's fine inside the prefab. Outside the prefab, I will want to just give it a rotation of 0. Perfect. So now the card's all done, and we just go on to the game manager. Okay, so before we make the game manager, I'm going to need enough card data. So I'm going to go into here. I'm going to create a new folder. I'm just going to call this tutorial card data. I do have some from before. It's using a different class because essentially I need to make a different class if I'm going to showcase this a second time. So we rename this, and I can just say cactor, and I'm just going to do this 8 times, just create a bunch of card data. So if you remember, it was create, right click, card data, and then I'm just going to fill out these numbers. Okay, so I've just quickly gone through and created 8 pieces of card data. Each one has a unique image and name, and each one has just a unique set of numbers. So we can now go in and create a script. And this is our game manager. And if we load up our game manager, the first thing we're going to want to do is define some stuff. So the first thing will be, what actually is our card prefab? So we'll just say a public game object, and we'll say card prefab. And that way we'll be able to tell the game manager what it needs to instantiate whenever it wants to make a card. The other thing we'll need is the public card data, and we're going to want to make this an array. So by using these square brackets, we're creating an array of card data. And what that basically means is it's not just a reference to one piece of card data, but it could be hundreds or thousands or whatever number you need, essentially. And it's just card data. So we go like that. Now, just to go back into Unity, we're going to, I've got this board I've set up earlier. I'm going to put in, we had the old board manager, but I'm going to actually put in our game manager now. I've turned the board manager off. So I'll just make sure I save the game manager. And then if we go in here and we turn off, look away from the board manager. So I'll put the game manager script on the board I created earlier. And now we have an array for card data, and we have our card prefab. So I can take this card prefab that we made today and put it in there. And the card data, I have an array, I have 8 worth, and I'll go into the ones I've made today. I'll click on the board and I can just drag these in one by one. And this will be all the different cards that we can spawn. Cool. So now we've told the game manager, what does our card prefab look like? What's the card data? And we can basically inject that card data into any card prefab we instantiate, changing its numbers, changing its image on the fly, essentially. So if we go back to our game manager now, so in our game manager, we're going to want to basically tell it when we're starting to drag a card, and then manage our card movement, essentially. So the first few things we'll need is to know, we'll need a Boolean, and we need to ask the question, essentially, are we dragging a card? So is dragging card, by default, it'll be false when we first start. We'll also need public bool is player turn. And then I'll say, it probably should start true, so we go first, essentially. Though you don't have to go first for the player, but that's how we'll set it up. I'll also need a reference to private game object, and we're going to say this is the dragging card reference. So this is the reference to the card we'll be dragging, and we'll also need a private vector free. So this is the start position. So I'll just call this drag card start position. So this is the starting position of the card we drag. So remember, we put a method in our card. Once it's clicked, it can send a message to the board manager, or the game manager in this case, and tell it that a card is being dragged. So what we'll need to do is do the logic of, I'm just reorganizing this slightly. So what we'll now need to write is the logic of when a card is being dragged. So first we will need to send a message to this game manager to say when a card has been dragged. So I'm going to create a method called public void onDrag start. And then essentially what I'm going to say in this is we're also actually going to want to tell it what card is being dragged. So we'll just say game object card. So what we need to do is say, hey, is the card being dragged already? So is dragging card false? So you're not already dragging a card. And we need to ask the question, is it our turn? So is your turn, is player turn, sorry. And then you can write this as equals equals true, or you could just write it like this. It's basically the same thing. You're just saying, is this false and is this true? If that is the case, then we actually want to say, okay, we are dragging a card. It does equal true. And then the dragging card reference that our game manager is looking at is actually the card that we told it. So we'll be putting this into our card manager shortly. And then we'll say dragging card start position. So drag card start position is equal to card.transform.position. So we're going to need to communicate from our card that this method is being called. So we're going to need a reference to our game manager. Now, because we only have one game manager and there's only ever going to be one game manager, what we actually want to do is set this up as a singleton so it can be referenced by any card in the game or any script in the game, essentially. So the most standard way to make a singleton would be we create a public static game manager and then instance. So on awake, what we'll say is if instance equals null, instance equals this, else destroy game object. So all we're doing here essentially is we're creating an instance of the game manager and we're saying, look, if this instance is empty, then this is the instance of the game manager. If there's two of these, which there should never be, we're going to destroy this. Now, the reason we've done this is now any card, any script, I should say, in the game can actually reference our game manager. So we can now go into our cards. We can now go into the card manager. And remember where I said here, oh, we've clicked on the card and we need to tell the game manager that a card has been clicked. Well, now we can quite literally say game manager.instance. There should only be one of these. And we can call any method we've got. So we say on drag start, and then we'll say this, because actually game object, this start game object would also work. And so what we're saying to the game manager is, hey, this card has just been clicked. And we're sending this card's game object data into this method. And then if we go back to the game manager, quite literally, we've got on drag start, we're pushing the card through, and we're saying, hey, this is being dragged. This is the card that's being dragged. This is its transform, its position even. And so now the game manager knows that that card's been clicked. And because dragging is true, no other cards can pass their data through until the dragging has stopped. So what we'll then need is a public, well, actually it can be private method, and we'll call this dragging card. And this is the code that will be running when a card is dragging. And so what we'll say is, and we'll make sure this is running every frame. So we'll say on update, if a card is being dragged, do dragging card. So every frame, that's what update is being called. So we're just saying, hey, is a card being dragged? If so, we start dragging card. And this will be the actual logic where every frame we're essentially updating the card's position. In this scenario for the game we're making, I've done selection via mouse. There's all sorts of ways you could select cards, drag cards, move cards, but we're doing it via the mouse. And in that case, what we need to do is get the mouse's position. So we'll call this mouse position. We'll say input dot mouse position. Oh, I need to put an equals there, my bad. So we'll put input dot mouse position. We then need to say mouse position. We'll put input.mouse position, and then we'll need to say mouse position equals camera dot main dot screen to world point, and then mouse position again. And so essentially what this is doing is it's taking our mouse position as like a 2D grid, which this is essentially on the screen, and then finding a point in the world, so an actual 3D transformation. And then because our board, how I've set it up, is essentially in the y-axis it's 0, what I can say is mouse position dot y equals 0.1f. Now, I think it's worth me going back into Unity and showcasing how I've set up the board. So the board it was a plane, or a quad even, but doesn't really make a difference. I've rotated it 90 degrees in the X, so it's lying flat, and it's just slightly below the Y axis. So if I rotate my camera, you can see Y is upwards, X is to the right, Z is forwards. So what I'm essentially doing is saying, what is my mouse position? And then because I've set the Y to 0.1, I've essentially aligned it here. So regardless of the angle, regardless of where I'm moving my mouse on the screen, the mouse is always just hovering over the board. So it's kind of like a way of taking this. You can think of the camera as a 2D plane that we're looking through. And instead of the mouse being locked in that 2D plane, it's essentially locked down to 0.1 in the Y. So we're always moving that way. I've got my camera also set up just, if I click on it here, pointing down on the board. So it's also rotated 90 degrees in the X, and it's over the board. And so whenever I click play, that might showcase it a little bit better. Essentially, my mouse is going to line up with the board. The cards are only going to ever, because I'm using the mouse position to move the cards are only ever going to hover slightly above the board. You wouldn't want them to be like where the camera is, essentially. So if we go back to the script, so mouse position Y 0.1, and then the dragging card reference, we're going to say transform dot position equals mouse position. So essentially, all we've done here is said the card's going to follow the mouse. Now, I'm going to need to tell the script what happens when we release the mouse, when we let go of it. So we'll say input.get mouse button up, and then it'll be 0. So this is just left click is let go of, essentially. And then we're going to need to write some script here. Now, what I'm going to say here is card is dropped, find location on board, or send back to hand. Now, what we're going to need to do now is actually set up the grid of the board. It's a very simple grid because it's just a 3x3, but we need to set up the grid on the board to actually start telling it where it's going. But if we go back into if I save this, we go back into the game, I believe we've done enough of the code so that this card should move. It's worth noting I forgot to put the box collider on here. And then if we press this button here, it gives us the box collider's, I guess, outline is the best way to describe it. I'm just going to line this up roughly. It shouldn't matter too much. It's mostly flat. It's mostly lined up. Obviously, in a real game, you would be very... I've made a mistake here. I need to copy component, remove component. I need to make sure I'm actually in the game object. And that's actually a good thing, that mistake to make. So can I paste the component? Probably not, because I delete it. No, I can't. Okay. So yeah, I need to make sure I'm actually in the game object, the card. I need to make sure I'm in the card prefab when I make any changes, because if I'm outside of it, so if I click to go in, if I'm outside of it and let's say, I don't know, I add a sphere, you'll see this green plus here. This means that I've edited it in this scene, but the actual card prefab I have doesn't have this sphere. So I need to make sure whenever I'm editing the card prefab that I'm actually inside of it. So yeah, we've added the box collider now. So if I press play, I'll be able to click the card. One thing I'll need to make sure is it's set to is friendly and it's not on the board. We haven't coded that part of the card. Well, this card isn't even instantiated, but we haven't coded that stuff yet. But as I click on it, now it's following my mouse and following the board. It isn't like floating too high up. So I can't drop it. So what I need to do now is make sure the board is set up. So we have a grid where this image is, a 3x3. And we need to basically be able to detect where it is in that grid and be able to drop it. If it's outside the grid, we can just drop it back to our hand, like the player didn't actually play the card. Okay, so to create the board, it's actually very simple in this situation. So we need to say, Okay, let's just name our variables or organize them. So this is variables for dragging. This is game state, and this is card data. So we just need, I guess I can put in game state. So we'll say public, it can be private actually, private game object. So it's going to be an array of game objects, and it's going to be a two-dimensional array, right? Because it's 3 by 3. So you can have the x-axis essentially, or the y-axis going down, can be game objects. The game objects in this case are the cards, and the board will be a 3 by 3 of that. So we'll call it like board position. So on start, we're going to need to say board position, and then I'll just say equals new game object, and we're going to make it a 3 by 3. So essentially now we can assign any object into the grid anywhere in this 3 by 3 grid, and then say, hey, this is this card, it belongs to this position. So we have a reference to where that card is. So from here, we'll be able to now say, hey, if you drop a card in a certain spot, we'll work out which spot that is and then assign it to this array. And then we have the data stored of where the card is. And if we ever need to compare two cards, like we often do in this game, we'll know which ones are next to each other. Now, we come to something that's going to be a little bit complex, and there's actually a lot of ways we can solve this problem. What I'm going to show is probably a good solution for something of this size. But if you start getting to more modular games that are larger, the system probably fails and you probably need something more sophisticated. But for this, what I'm going to showcase is I'm going to take this image and go into Paint. Okay, so I've opened up Paint here because I'm going to need to explain how I set up this grid, and it's not the most intuitive thing in the world. So in Unity, this point here is the origin, and it's just 0, 0 in the XZ directions. So because that's the origin, and I know the width of each square, and I know the height, which is the width is 17 and the height is 18. That's just because of how I set it up. However you set up your board, it will have a different length and width, or width and height even. And so what I need to do is basically know these bounds when I go from one square to another, so I know where to place my card. So if I know this is 0, I know exactly in the middle of here would be 18 is the width. So I know 18th's the width, I know 0's here. So it's essentially, is anything above 9 would go into this square, anything below 9 would go into this. And there's a really easy mathematical solution here, which is I basically take my x coordinate, I would divide it by the width, which is 18, and then I would get something. So let's say I'm on this line, I would get 9 over 18 would be 0.5. And then what I can just do is use a function of rounding an integer to a whole, rounding a float to a whole number. So 0.5 would become 1. Anything below 0.5 would become 0. So what I can then do, so I'm rounding this number that I get from dividing x by 18. And so it's anything past this line would end up here, which is 1, and this would be 0. So what I can do is essentially think of this grid as 0, 1, minus 1, and then in the y, it's 0, minus 1, 1. And then when we start considering the y and the x, so this is x1, but it's 0 in the y, and it's also 0 in the y. This is 1 in the y, it's 0 in x, sorry. And so very quickly, I've got a grid. I've got a grid of numbers that will represent where exactly I am. And obviously here would be 1, 1. And so I've got a mathematical function which is I round to the integer of the x or y axis, each divided by the length of the squares I'm using. So now I would get a grid of numbers. Now that might seem quite confusing, but then what I can then do is I can put these numbers, these coordinates, and I can input them into my array. Now, unfortunately, the way arrays work is they go from this would be 0, and then this would be 2, 2, for example, this square down here, and this one would be 0, 0. So I'm going to, whereas this would be -1, -1 using the system. So I'm going to have to convert from one coordinate system to another, and it's literally just +1. But I'm just showcasing the maths here. Hopefully you understand it. I'm going to write out the code now, and then hopefully, we won't save that. Hopefully it should click in your mind. There's probably 100 ways you could write this. You could use hitboxes, you could use different coordinate systems, you could neaten it up. I'm just showcasing it this way. It is a very simple system at the end of the day. It's a simple grid. I'm sure people in the comments will be like, oh, I would have done it this way 100 times simpler. This is just the first way that came to mind. I know it's a little convoluted, so I just wanted to take a moment to try and explain it to people. So in the dragging card function, we need to say, well, where is the card dropped? So we're going to use that maths I was talking about. I'm going to just create a new variable, and I'll call it drop x. And we'll say new int drop x equals, and then it's math f dot round to int, and we're going to put in that equation. So it's mouse dot x, and then it's divide by board width. Now I need to define my board width and my board height. I can put it here, so it's private int board width is 18 and my board height is 17. Cool. So we've got board width and board height, and we've coded that in. It doesn't like me setting a new int here actually, so I'll just say drop x, and then here I'll just say private int drop x equals 0, drop y equals 0. I do want to capitalize the x and the y there. Cool. And then so I'm just doing drop x, and I'm getting that. I'm also going to need to do my drop y. So this is the x and y coordinates we're dropping into, as explained in that paint document. 0, 0 is the origin, -1's anything to the left or up, and 1 and 1 is to the right and down. And we're going to then say, okay, if what we dropped was inside the board, so that would be drop x that is greater than or equal to -1, and drop x is also less than or equal to 1, equals to 1, then what I'm essentially saying, okay, it's both above -1 and below 1 or equal to, therefore it did actually fall inside the board. I'm going to have to do the same with drop y in the x, in the minus, so it needs to be larger than -1, less than 1. And so what this has told me is that the card has fallen somewhere within the board. We'll do an else statement at the end of this. So card is in board, card dropped on board. We'll do an else statement at the end of this to say, oh, it wasn't placed in the board, go back to the return start position, essentially. So now we need to also say, well, is our board empty? So we're going to say if board position, and remember this is the array, 3x3 array that's defining what game objects are where in our game state. So what I need to do is say drop x +1, and then drop y +1 is not null, or is null actually, is empty. So I need to check that the board position is empty. And you might be thinking, okay, why are we doing +1 again? Now, arrays in almost all programming languages start at 0 and they end whatever length they are. So it's a 3 by 3. So what that means is the x-axis is the free slots are 0, 1, and 2. And the free slots in the y are also 0, 1, and 2, because the array starts at 0. But what's weird is the length is 3. So you think it would end at 3, but if you start at 0, you end at 2. And it just so happens, which is fine, it's almost irrelevant to this. And then it just so happens that the grid we've created, mathematically, how we're finding the location, is a 0, 0 origin. Whereas the board, if we were using this, the origin, the center square is 1, 1. Now that still might be confusing. I'm not really sure if there's a better way to explain it. So what we need to say is, look, the board's empty, or a card got dropped on the board, and the slot it's dropped into is empty. And now we need to then assign our card to this board position. So we'll take this again, the same board position, and we'll say, okay, that now equals the dragging card reference. Because this is an array of game objects, we've got a reference to our card previously, and we're just saying, look, this card now belongs to this slot. We now need to also give it a new transform. So I could say this dot game object, or I could just say dragging card reference dot transform dot position is equal to a new vector 3, and it's drop x drop y times board width times board length. Right, because we're using this to calculate where the mouse was. It is worth noting, actually, it's drop y in the z-axis times by board height. And you might be confused, why is my y value going in the z-axis? Because I'm conceptualizing this board for you as I'm thinking in like 2D graphs where it's like x and y going downwards. However, if we look here at this gizmo, y is actually the positive, it's the height relative to our board being flat on the floor, if you want to think of it that way. So we're actually, in terms of positions, it's positive z and then positive x. Oh, I was explaining it in Paint wrong, which adds to the confusion. Y positive is upwards. I was saying Y positive was downwards, but that's not the case, because obviously this is positive height, and then if you divide by the height, it would, so this is Y, this is -1, -1, this is 1, 1, if that makes sense. Okay, so we go back in here. We've assigned the new position of the card. We've told the card where it is on the board. We would then say dragging card reference dot get component, and then would say card. We'll get the cards component, and then we'll say is on board equals true. And if you remember on the card manager, what we actually coded earlier is if it's on the board, you can't actually drag it. So once the card's placed on the board, you can no longer drag it. So by updating this variable, we've made it so the card can no longer be dragged, and we're telling the card script that. I also want to say is your turn, is player turn, in fact, is what I called it, equals false. It's no longer our turn. We've just played our card on the board. It's no longer our turn. Now, what I also need to do is finish the else statement and say, well, if the card didn't get dropped on the board, or the card slot isn't empty, we need to say dragging card ref dot transform dot position is equal to dragging card start position. Where did I set that? Drag card start position, sorry. So we're basically saying, look, this board square wasn't empty, therefore go back to where you came from. We also need an else statement for this if statement. So I'll just put it here. And it's the exact same thing. So if the board state isn't empty, the card needs to go back. If the card got dropped outside the board, it also needs to go back. And then at the end of all of this, we need to say, and then at the end of this if statement, when the button gets pressed down, we then need to say dragging card. So at the end of this if statement, we also need to say is dragging card now equals false. So we're no longer dragging the card. So now if we go back into the game, we press start, I should be able to pick up the card. And if I drop it outside the board, it will return to its start position, which is correct. And then if I put in any slot, it will just slot in. So I understand that maybe that wasn't the most intuitive explanation, but we've got a pretty simple board state now where we can just drop in any card pretty much anywhere on the board as long as it's not filled with a card already. Okay, so we've now got it so we can drag one card, but we're now going to need to do two of the main things left in the game. So now we can drag cards. We're going to need to instantiate a bunch of cards for us, the player, and we're also going to want to do the same thing for the enemy. So there's 5 cards for us, 5 cards for the enemy, and we're going to spawn them in and essentially assign all the data to them. And then from there, what we will need to do is obviously allow the AI to place cards. We want the interaction between the two cards if the numbers are smaller or lesser. And once we've done that, we've pretty much made the game. That's pretty much the core of what this game is. So there's just a few more stages left. But first things first, I'm going to show you how to instantiate cards for the player and instantiate cards for the enemy. Okay, let me showcase how we're going to instantiate these cards for the enemy. So this would happen on start, but I can organize it in its own method, so it's just a little bit neater. We'll just say instantiate cards. That could be the method name. That seems fine to me. And so the first thing we're going to want to do is do a for statement. We're just going to say I equals 0, and then as long as I is less than 5, so it'll do it 5 times, and then we'll just say I++, and then there we go. And then, so essentially what we're trying to do here, I need another parentheses. What essentially we're doing here is saying, look, I starts at 0. Every iteration we go up by 1, as long as it's less than 5. So that'll be 5 iterations because we're starting at 0, not 1. And we're going to generate a card. So we can generate the player cards first. So we'll just say we need a random number. We have a new int, random number needs to equal a random range. And that range is going to be 0 to 8. Now, random.range is min inclusive, max exclusive. So we go from 0 all the way to 7. And 0 to 7 is 8 numbers. So 0 to 8 in random.range gives us 8 random numbers. And then what we can do there is use this random number to tell us which card we're getting from the card data. But first we need to instantiate that card. So we'll say game object, and then we'll say temporary, and we'll say equals instantiate card prefab. And this is the card prefab we've referenced earlier. We need to give it a location on the board. Now, I've worked this out earlier in my previous script, so it's -44. I'm sorry, it's a new vector 3, and the x is -44. The the y is I times by 0.01f, and then the z is 20 plus I minus 10. Now you might be looking at this and being like, what the hell? And then the rotation is quaternion.identity, because I actually don't care about the rotation. So I just wanted to explain these coordinates quickly, because you might be looking at these and being like, what? Why would any of what does this mean? Minus 44 is quite literally just here on the board in the x-axis. The I times 0.01f is what that's going to do. This is the y-axis, which is our vertical axis. It's going to layer the cards on top of each other so they kind of look stacked, or like, well, essentially layered, so like they're not overlapping each other and glitching out. The 20 plus I minus 10, so 20 in the y will probably, it'll be here. And then what I'm doing is, oh, actually it's up here. And then what I'm doing is every time a card is spawned, I is increasing by 1. So I'm minusing 10. So one card will be here, then the next one will be minus 10 down, minus 10 down, minus 10 down. So they're layering in the Y, they're fanning this going down in the Z, and then in the X, they're just a static number. You might wonder how you come up with these numbers. Essentially, static numbers, you could just quite literally do, create empty, create a cube, let's say. And then if I create a cube, pull it out, and I can literally go, oh, this is where minus 44 will be. Obviously, so minus 44 is here. I can then look at, I want my Y to be like, it is going to be 0.01. And then in Z, you can be like, I want to go down minus 10. Or you can say, I want to roughly have something here. I go down, go down, go down, and see the difference in the Z. So you can kind of use just a generic cube or something like that, just to kind of plan what sort of numbers you want to be using, where you're going to position stuff. And then you can think of the basic maths as like how that handles it. It is worth noting that obviously the first time you do those sorts of numbers, they'll probably look bad. You won't have the right position or whatever. There's a little bit of trial and error, just making sure the placement of the objects you're instantiating is how you would like. But I just wanted to showcase how I got those numbers, just so you're not lost if your scene's set up slightly differently than mine. I'm going to now need to get a reference to the card manager script. So I'm going to say card manager script, and I'm going to say temp script, and I'm just going to say get the component of temp, do it like this. And so I now have a reference to the script, and I can start to inform the card about itself. So I can say temp script, your card data will equal card data. So this is the array of card data we have up here. And I'm saying, well, you're going to take a random number we generated earlier, which is 1 to 8. And I'm essentially saying, hey, the card data I have on my board, which is here, these 8 elements we made earlier. These 8 elements we made earlier, we're getting a random number to pick one of these. And then in that random number, we're now assigning it to the card's data. And if you remember how the card manager works, if we go back into here, the card manager has its own data assigned to it. And then when it is instantiated, it now knows to set up its numbers and to set up its image based on that card data. So us instantiating this object and then giving it its data, we're essentially telling it what card it is. We can also say temp script. And because this is our friendly cards that we're making, we'll say is true, and then we'll say temp script, and then we'll do set color, and then I will put, and how did I organize this in my card? So set color, and I'm asking, is it friendly? If it is, it's blue. If it else, it's red. So I just say set color, and I say true. And because that's a true statement, it is friendly, it will be blue. When I make the enemies, I put false in there, and I'll get the red color. So I can literally copy and paste this, and I'm going to go through this again, but now for the enemy cards. So we want the same amount of cards, so this for loop doesn't change. We're going through the random card data, or we're using a random card from the card data, so that doesn't change. We're going to instantiate the card, Instead of -44, we're actually 44 because we want to be on that side of the board. And then our everything else is the same. Rotation is going to be the same because this is the Z, this is the Y. That doesn't change anything. Or the Y and then the Z. It depends how you're thinking about it. We'll go through the card manager script. We could grab the script again, and then so we grab the script again. We do want to give it a random data. We are going to say false. It isn't going to be a friendly card. And we also want to set the color to false so it turns red. Okay, so now if I go back into my scene, I'm going to delete this card prefab that I've essentially instantiated into the scene previously, and I'm going to press play. I forgot to actually even run this method. So we've created the instantiate card methods, and then so on startup, we're just going to instantiate cards. Boom, boom, boom. Save it, go back into the scene, press play, and now we've instantiated our cards. Now I've done two problems here. One is I've not fanned these out correctly, and I'm not a huge fan of the colors. So the reason they weren't fanned out correctly is it's I times by -10 and it's I times by -10. So if I correct that, they should fan out correctly. And then we press play. Cool. So my cards have fanned out correctly. The blue color and the red color is not what I want either. So I'm going to just fix that also. Okay, I just double checked why the blue was so bright. In my other shader, I did this slightly differently. So you remember we took the UV green, and then this gives us a mask of white to black. And then I took the green channel out, and then I multiplied it by the background blue, and we get that. Because we're using like default blue, so it will look something like this. All I did instead was, instead of multiply, which gives us the color we're getting, I did add. So this is a white to black gradient, and if you add it to a pure blue, you get quite a light blue. And then I can offset in the Y, and then I can tile it, and I can get like a nicer looking color like that. And essentially what I'm doing is I'm taking the blue, and because I'm adding white, I'm like lightening it. Whereas before, what I was doing is I'm just taking the blue, multiplying it by the white. So that's it's just keeping the blue value, if that makes sense. White is essentially a 1. So if you multiply something by white, you get the same value. If you add white to an image, you're essentially going to lighten it in a sense. So this is a bit nicer looking. I plug it back into my shader. I save it. And now if we press play, right, we've got a better color scheme, in my opinion. We've got our cards now. We can move these cards. I haven't set up the AI yet. So once I play a card, I've told it it's now the enemy's turn. They can't play and I can't play. So we now need to tell the AI, well, it's your turn. And we need to tell them how to play their cards, where to play their cards. And then once they've played their card, it needs to become our turn again so we can play another card. And then we just need an end game state where like, oh, the board's full, game's over, no one can touch any more cards. So if we go back into our game manager script, and what we need to do is say, okay, we need a new method. And this is just going to be enemy phase. Enemy phase, so the enemy turn, or it could be enemy turn, it doesn't really matter. And then what I need to say is every frame, I'm going to just say if it's not our turn. So every frame, I'm just going to say if it's not my turn, so exclamation mark is your turn, is player turn, sorry. So what I'm going to do now is say in the update function is player turn. I'm going to put an exclamation mark. So it's not our turn, it's the enemy turn. then if that's true, then we need to do the enemy turn method. And so the reason why I'm putting it in update is it's essentially whenever it becomes not our turn. There's probably a more efficient way to do this, if I'm being honest. Like I probably would say on the dragging card thing, where I do here, it's like, oh, it's no longer our turn. I could call the enemy turn here. I'm trying to think if that works and if that's more efficient than like doing an if statement every frame. Because it will only become their turn. Yeah, I can just do it here. I'll do it here. It's not how I did it before, but it's essentially the same. So every time we take a turn, the enemy takes a turn, which is should be fine. I may need to make an if statement around this just in case I don't want the enemy to take a turn like the game's finish. So we go to the enemy turn. So the enemy AI that I'm going to make is going to be very basic. So in the real Final Fantasy minigame, there's multiple rule sets. I think certain NPC characters play the game slightly differently. There's all sorts of strategies you could think of. I'm rather just trying to get the proof of concept down. So I'm just getting the AI to play random plays, picking random squares, picking random cards. Obviously, it can be quite challenging to make an interesting AI that isn't always picking the most optimal thing, but picking something that's strategically interesting or challenging. I don't really think that's within the scope of this tutorial. I think we're just going to showcase how we would do the most basic AI for this game. Okay, just before I go into coding the enemy turn, there is a bug I found that I wanted to fix. I've put here mouse position Y. If you remember, Y is the up-down axis or the height. In reality, I want the Z axis, so it needs to be mouse position Z or Z. That will fix the bug. It was very simply just me mistyping that earlier, and that was in the dragging card method. So we need to now do the enemy turn. Now for the enemy turn, I probably want to keep a list of all the slots available on the board, or the board positions. And so what I'm going to do for that is create a list. Okay, so for my list, I'm going to do private list. I'm going to do int x, int y, and then I need brackets here. And then I'm going to call this list empty positions. Now, I'm going to want to set up the empty positions on initialization. I can do that in the Instantiate Cards function. So I'm going to say, because this runs once at start, I'm going to say also empty positions equals new list, and we'll just create a new list. And then I'm also going to want to go through every board position. I'm going to want to go through every board position and add it to my list. Okay, so for this loop, I'm going to do for int equals 0, and then I'm going to say int I even is less than, and it's board position dot get length, and we want the length in the x-axis. Rather than using I probably want to use x. So x, and then x plus plus, and then what we'll do in here is then do the exact same loop, but we're going to do the loop for the y-axis. And instead of length on the 0, which is the x, we'll do length in the 1, which is y, and then y again. And then in this function, all I need to do is say, so we've got empty positions dot add, and then it'll be x, y. Very straightforward. I'm missing some brackets, I believe, because I'll do this. Yes, so with these brackets in place, so now every time we instantiate the board or the cards at the start, we'll get a list of all the empty positions in here. And what we can now do is randomly go through them and tell the enemy on their turn to essentially pick one at random and place a card there. So we're going to need a new method, and we'll just do private void, and I'll call this enemy turn. The first thing we'll want to do is get a int, and we'll say int random position, and we'll say is equal to random dot range, and then it will be empty positions dot count. So empty positions dot count. So now we have a random position to go to. We also need to pick a random card. So I'm going to do the same, and I'm going to go, I guess it will be a list of game objects I can do. And I'll say game object, and then I'll say enemy cards. And then how will I fill this list up? Probably the easiest place to do that is here, where I instantiate all the enemy cards, and I just say enemy cards dot add, and then temp is the name of the temporary reference to these cards. So I'll get a list of 5 cards in this situation, and I'll just say int random card equals random.range, and it's between 0 and the enemy cards count. Because this is min inclusive, max exclusive, it will just go 0, 1, 2, 3, or 4 in that range, in that list range. So now what we need to do is assign the random card we've picked to the new random position. So we'll start this off and we'll do an if statement, and we'll say empty positions count is greater than 0. If there's no empty positions, we don't actually want the enemy to take a turn because there's nowhere they can put a card, simply put. So now all we need to do is assign the board position. So we'll say board position, and we'll say it will be the list of empty positions, and it's going to be its index, which is random position, and then we want it in the .x, and then empty position random position .y, and then equals enemy card, right? So it would be random equals random card. Random card, sorry, is enemy cards, keep mistyping, enemy cards at position random card. So the random card we picked is going to be put in board position, and it's the random position that's available. And then what I also need to say is enemy cards dot remove at, and then it's random card. And we also need to do enemy positions, or empty positions more accurately, remove at, not random card, but random position. So we've added this random card to the random position, we've removed the card from the list of available cards to play, and we've removed the position from the available thing. So this function does, it assigns everything, but we still need a way to move the card. Now I'm probably going to do that in a coroutine so I can animate it. It's also worth noting that I need to set is player turn back to true, equals true. And then from here, we're going to need a coroutine to animate the card into its new position. Set up a new coroutine, call this card animation, and we just need to temporarily put yield return null, and I'm also going to want to start coroutine and say card animation here. Now the problem we're going to run into is I didn't set this up as a coroutine itself, so I'll do IE numerator, and we'll do enemy turn, and I also need to do a yield return null just at the end here. It isn't necessary, but it will need to be done temporarily. One thing I need to do as well is I need to say when the enemy turn is actually going to happen. So I'm going to take this coroutine, and I'm actually going to say whenever we play a card, we're going to start the enemy turn coroutine. So I'll just plug that in instead. And so simply put, we're dragging our card, we've dropped it, the enemy turn starts. On the enemy turn, we're going to pick random position, random card, place it, but then we also need to do an animation so it travels to its new location. Now, within this animation, we're going to need to pass some details. So the details we need to pass through are going to be game object. We need to know which card we're moving. We need to know vector 3, its start position. We need to know vector 3, its end position. And we also need to know the duration of the animation. So we can plug all these in. So the card is just going to be, in fact, I'm going to need to move this up. I need to start the animation before the cards are removed. So I'm going to say it would just be enemy cards, random card is the reference we want for the card. The start position is, we won't need a start position. Instead, we can just do it this way. And the end position is going to be a new vector 3.random position.x, which is a bit long. We probably could have simplified this at some point. And we're going to do -1, and then we're going to times by board width. Empty position times by board width. In the y, 0.01f, and then the last position is going to be this empty positions.random position or the random position, but it's the y is still -1 and it's still times the board width. Or no, sorry, it's times by the board height. Then we don't need a comma here, misspelled that, and I just need to check my brackets. I think I need one more. Then I also need to set the animation time. I'll just do 1F. So this new vector free, this bracket ends there. This bracket ends there, this bracket's there. So board height is capitalized and cool. Okay, so we have one extra bracket than we need here. If I save that, and then there's one more bracket here, right? Cool. So I was just getting all my brackets right. It's a bit messy, this line, but we start the coroutine and we have the card that we want to move, the position we want to move it to. I'm just going to say it's going to take 1 second to do the animation. Now we need to actually code the movement. We go into our card animation, and the first thing we'll want to do, so I want an if statement here, and I'm going to use the moving bool we set up earlier, and I want to say if it equals true, we yield break, and then I'm going to say moving equals true, and I'm just checking, yeah, I did set up this bool earlier, equals false by default, and then I need to do a vector free. I'm going to say start position, and it's going to be equal to card.transform.position. So we've got the start position. I'm also going to need a timer, float timer equals 0f, and I'm also going to need to set up a loop. So I'm going to set up a do while loop. So I'm going to say do this while something is true. So what I'm going to do is my lerp factor, so float lerp factor equal to timer divide by duration, and this is just going to smooth out our transformation. And then I'm going to say card.transform.position is equal to a vector free lerp, so this will move us to our end position, and we'll go from start position to end position, and we'll use lerp factor. And then from there we're going to say timer plus equals time dot delta time, and this means every time a frame goes by, our timer increases. As the timer increases, it changes the lerp factor, and this should be lerp, and this will lerp us from one position to another. Now we need to do all of this while timer is less than duration, and then at the end of the animation we need to say card.transform.position equals end position, just in case it hasn't lined up perfectly. That should be there. Cool. I also want to say moving equals false at the end of this. Cool. So this should be everything we need. I'm just going to go, I've saved, and I'm going to go back into Unity and just double check that this works as intended. Okay, it's not lerping at all, so that's a problem. It is moving to the board, but it's not lerping. So we do need to fix that. And it did go one more time when the board was still full. So we need to fix those. Okay, I found the source of the bug. It was that here, I forgot to type yield return null. So now the actual animation should play. So if we press play here, cool, we have an animation. There is another bug I did discover, which is, I wonder if it will show itself, which is there's sometimes overlapping cards. Now, the reason that's happening is when I assign a card myself, I am not removing that from the empty positions list. So when we drag a card and we assign it to a position, we're not actually removing that specific empty position anymore. So we do need to say, look, empty position. So the syntax for this is empty positions dot remove all, and we will want to remove position X and at drop X, and then position Y at drop Y plus 1. So let me just double check that this is all working. Perfect. So now everything's working. We have the AI playing their turn. We have all our board positions being tracked and whether there's any available, and so there's no like playing on already played positions. We're able to play all our cards, the enemy's able to play all their cards. The final thing we need to do is actually compare the cards when they're placed. So if you remember at the very beginning of this video, I told you that when I place a card, for example here, he places a card that's, if I was to place, I've got no good examples here. If I was to place a card, he places a card. Now if again, I've got no good examples, that's insane. Okay, perfect. So if you remember at the beginning of the video, how this game actually works is these numbers here, so this 7 here would correlate to this 6 here. And if this 7's higher than this 6, this card should flip and turn red, it should essentially become an enemy card. And the whole point of the game is you're trying to flip as many cards to your side as possible. So what we need to do is just do the final function, which is whenever a card is played, check that board position. If it's friendly, flip it for the friendly. If it's an enemy card, we flip it for the enemy. So let's start writing that method now. Okay, so starting this method, I'm going to make it a coroutine because, again, it's going to have some animation. So IE numerator, and we'll call this card phase. And we need to pass through some details. We need to know the X position and the Y position of the card being played onto the board. And we also need to know, is the card a friendly card or an enemy card? We can use a bool to work that out. I'll just write yield return null for now so we get rid of the error message. So I'm going to need to say, I'm going to want this to be dependent on whether we're in a card phase or not. So I'm going to create a bool up here, one more, private bool, and just say flip phase, right? And it's going to be false by default. But when we enter here into our card phase, we're going to say the flip phase has started. So we're going to say true. So I'm going to need some details. So I'm going to need the card manager script. This was the name I was using for this tutorial, card manager script. And we'll call this card, and it's going to be of board position. And then we're going to say X, Y. So we took the X and the Y as arguments, and that's going to tell us card in that position. And we just want to say get component, and we're going to say card manager script. And then that way we have a reference to the script we're going to be changing. So the first thing I want to do is try and compare where my card is on the board to the other cards on the board. So what I'm going to actually need to check is if this card is touching a boundary. So for example, if X is less than 2 and board position is X plus 1, Y does not equal null. What this means is there's actually a card to the right of this card. So if you understand this, basically, if it's less than 2, the card isn't on the rightmost edge of the board. So it's either in 1 or 0. And then what I'm saying is, hey, if we go plus 1, look to the right of this card, and it's not a null position, that means there's a card there. So there's a card to the right of this, and this gives us some information that we can work with. So now I need to compare these two cards. So I'm going to say if card.cardData.WriteNum is greater than right card, so the card to the right .CardData.LeftNum. So if our right number is bigger than their left number, we're going to need to flip the card. Now, to know what we're flipping the card to, we need to know, hey, is our current card friendly? And is the right card is friendly equals false? So is it an enemy card? Is our card friendly, and is it an enemy card? If so, we need to convert card to player. But then we also need to say, hey, if it's not friendly and right card is friendly, well, actually, we need to do the exact opposite. We need to convert right card to enemy. Right, so here we're just checking, hey, is our number bigger? And then we need to ask the question, fundamentally, where are we converting it? Friend to friend or enemy to friend? We need to know how we're going to convert it. It's also worth noting, for example, if it's not a friendly card and the right card is also not friendly, then it just doesn't matter. Nothing happens because those cards won't interact. Enemy cards don't interact with enemy cards, and vice versa. Friendly cards don't interact with friendly cards. So to do the conversion, we need to say right card is friendly now equals true. We also need to say right card set color is true. And I'm also going to need to say right card is on the board, because we use that for our cards, but we haven't been using that for the enemy cards because it hasn't been necessary. And then we just do the inverse here. And we'll say false because it's no longer friendly. And we're also going to set the color to false. And if you remember, we were just using a Boolean argument to say either to blue or red. Now I'm going to need to repeat this for every direction. So this is currently checking the card to the right. I now need to go and write this for every position. So I won't bore you and show you all of that, but I'll just do that quickly. Okay, so I've just finished writing all of these for each direction. Now this is a nightmare for potential to get something wrong, because essentially, look, if we go from left to right, well, now we're not doing x less than 2, we're doing x greater than 0. We're not doing x plus 1, we're doing x minus 1. We're not doing right card, we're doing left card. We're not comparing the right number to the left number, we're comparing the left number to the right number. So you quickly realize it's this awkward position where essentially this code and this code are exactly the same. So you're just like, oh, I'll copy and paste them. But then every single variable, every little detail, greater than, less than's need to be changed, different data needs to be compared, all of this stuff. You make one wrong mistake here and potentially it just doesn't work as intended. So you do need to be quite careful when writing this. You need to comb through it. You probably want to test it afterwards and make sure it's working as intended. Then at the end, we just say flip phase equals false. And this is all good. And this is pretty much, we're right near the end. So now I need to actually assign my coroutine to the correct functions and say start coroutine. And we're going to do card phase. And card phase is going to be here. It's going to be X and Y. And X and Y are specifically empty positions, random position, X minus 1, and empty positions, random positions, Y minus 1 also. And then bool friendly, because this is happening in the enemy turn, the bool is actually just false. And then I think I have an extra bracket that I don't need here. And a second bracket at the end, and perfect. So this is the coroutine. So it's going to run through the card phase every time the enemy plays one of their cards. There's one other place we need to put this, and that is, of course, when we drop a card. So this was in the dragging card function, and it would be here, and we would need to do it before the enemy turn. So we just do here. Obviously, X and Y here are much more simply just going to be drop X plus 1 and drop Y plus 1. Cool. So that should start the coroutine here. We need to set this to true because this is a friendly card. It will always be a friendly card we play and an enemy card the enemy plays. One thing I just want to double check. So one thing I'll do is I'll start this coroutine. I'll cut and paste. I want to start it before I actually remove this empty position, so these X and Y values are not null. We'll save here and we'll go back into the game and see if this is working. Okay, it's flipping instantly. Yep. Cool, so everything's working as intended. The final thing we need to do, if you remember the other version that I showed you earlier, which I can showcase quickly once again, I think this is a cool little thing to add, which is the card actually flips. This is very similar to the actual game. In Final Fantasy VIII, where when you play the card, it flips. It's a cool little animation. I think it's worth trying to add that as well. So let's add the card flip, and then we'll be done with this tutorial. So I'm just going to minimize card phase for a second and just do another enumerator, i.e. enumerator. And I'm going to call this card flip. And I just need a reference to the card we're flipping and a duration of the animation. I can hard code this actually because it doesn't really matter. You can obviously create a variable, change your animation speeds and timings, but here I'll just hard code it. It won't really make a difference. So the first thing we want is a vector 3, and we're going to call this start height. We're going to call this start height. Oh, misspelled that. Start height, and this is going to be equal to card transform dot position. And then I'm going to say vector 3 end height, and it's going to be a new vector 3 And this new vector free is going to be start height x, start height dot z plus 10, and start height dot y. And so what I'm essentially going to do is I'm not going to flip the card in place because it creates an error. And that error is, you can essentially think the board and the card are right next to each other. If it flips in place, it's going to clip through it. So what I'm going to do is lift the card, flip it in the air, and then drop it back down, essentially. And by doing this, it makes for a smooth animation with no clipping. So then I also want a float. So I want a float, and I'm going to call this start rotation, and it's going to be equal to the transform dot Euler angles. So it's going to be equal to transform dot Euler angles, Euler angles dot x. And we're then going to do float end rotation, and it's going to be equal to the start rotation, and then it's going to be plus 360 degrees. So essentially, start rotation is just the rotation of my transform already. Oh, I made a little mistake here. It's not the rotation in the X, I'm rotating in the Z, of course. And I'm just going to get a start rotation of the Z, which is nothing, and then I'm going to rotate it 360 degrees in the Z. I'm going to say float t equals 0f equals 0f, and this is my timer essentially. And I'm just going to say while t is less than duration, I'm going to say t less than 1 because I'm hard coding it. But I could put this as, I could say, bool duration, not bool, sorry. I could go here and go float duration, and then I was hard coding it anyway elsewhere. But yeah, you can plug in variables, have control over your animations. For now, I'm just demonstrating how we would do the animation. The actual details you can always refine yourself. So while our timer is less than 1 second, I'm going to say t plus equals time dot delta time. So this is going to increase our timer every frame. It's just essentially a little clock for us. And then we're going to say card dot transform dot position equals vector free dot lerp, and we're going to go start height end height t. And then I'm also going to do float, and I'm going to say z rotation is equal to math f dot lerp. I'm going to do start rotation, end rotation, and then t divide by 1, and then I'm going to put 1 in here as well. Actually, I think this is a demonstration of why actually hard coding numbers is a nightmare, and I shouldn't do it. T divide by duration, T divide by duration, and then plug in here. I'm just going to say float duration. So we have the duration, and we'll do it less than duration. I think that's much neater. Me trying to be lazy just made things more complex, really. Okay, cool. Now we need to do card dot transform dot Euler angles dot equals new vector free, and it's going to be transform dot Euler angles dot x minus 90, transform Euler angles dot y, and then z rotation. Yield return null, important here, and then at the very end we'll just make sure it lines up perfectly. So we'll say card dot transform dot position is equal to start height. Cool. So if any of this wasn't super clear, I'll just run through it. We're getting the start height, and we're getting the end height of the card, and the end height, again, we're just moving 10 in the y-axis. Yeah, we're moving 10 in the y-axis. I don't know why I wrote z here, and this is actually our z. So that's correct now. We're then taking a start rotation. We're rotating 360 degrees. We're doing a simple timer, and we're just saying as the time goes on, we're going to take our position and we're going to lerp the height. So we're going to move up in the height. And at the same time, we're going to lerp a rotation. So yeah, these are the rotations I believe I've set up already in the scene. Then we're just returning each loop. And then at the end, we're just setting our height to our original height, just in case there was any, there's sometimes rounding errors in a lerp. So we then need to make sure we're calling the card flip whenever a card would flip. And so all of this will go into the card phase, and essentially it will happen here. So what we'll want to do is say yield return start coroutine, and it's specifically our card flip coroutine. Yep. And we need to say, well, first what card it is. So here it will be our right card we're trying to flip. We're then going to say .gameObject. No, right card's fine because we're referencing the card. And then we need to set up a duration. And then we need to close this out. So it's right card.gameObject. So we set up the routine here. So we're going to say yield return start coroutine. And we want to flip the right card if we're flipping, because obviously this is the one for the right card. And then we just copy and paste, and we're flipping its game object, of course. And we're doing the same here. We're going to need to copy and paste this several times, but changing the card each time. So we'd go here, and we're actually checking the left card. Luckily, we get an error message because the left card only exists in this area. Left card. Here we'll do down card. Here we've done up card. Cool. Now, it's worth noting there's always room to improve these animations, improve upon them. For example, you could take the set color and you could pull that into this routine. And so what you could have is actually when the card's first flipped down, you don't know what color it is. And then when it flips back up, it would flip to the color it needs to be. So there's all these sorts of refinements and cool ideas you can execute, but I just really wanted to get the broad concept of this game done and showcase it working. So if we go back, hopefully we have no errors. So let's just test. We can move cards. It is flipping instantly. So that is one bug that we have. When the enemy plays a card and they flip us, it flips instantly. Let me look back at the code. Okay, so the reason I believe we're getting this bug is at the enemy turn, we're not actually waiting for this animation to finish. So if we type yield return here, the card animation will finish before it flips. So that was the big error we were getting there, or the reason why the animation didn't look particularly clean. Okay, so now testing the game finally, it should only flip when they play their card. And it flips one of ours. Okay, flip two there. And I should be able to flip, let's say here. Cool. And this is pretty much it. We've made Triple Triad from Final Fantasy VIII. We've put it into Unity. There's a lot of room to make this more complex, to add more strategies, make the AI better, more music, sounds, slightly better animations, more artwork. So I hope this is a really good foundation that you guys enjoy. You should be able to build something quite cool from this. Obviously, you can use your own cards, your own artwork, start designing your own game around this, or maybe just take some of the broad ideas that you've learned in this tutorial and see if they can apply into other projects. I hope you guys have enjoyed the video. It would help a great deal if you subscribe to the channel or even like the video. I should be uploading these more regularly these days. Thank you, and I'll see you next time. Cheers. Bye-bye.